Hello! With this video, we begin the series on the synthesis of fenfluramine. The series includes an introductory video, this video, videos on retrosynthesis, and on the resulting syntheses. Here is presented the systematic name, CAS number, and the structures expressed in 2 and 3 dimensions for fenfluramine. It highlights that it is a di-substituted benzene by a 2-propanamine and by a trifluoromethyl group. Additionally, it has an asymmetric carbon. We can say that this drug originates from research on fluorinated amines with the general structure 1, which gave rise to the general structure 2, where the trifluoromethyl group can bind to various positions on the benzene ring. Additional optimization efforts culminated in fenfluramine. Its mechanism of action is still unknown. It has been proposed that it may be multifunctional, increasing serotonergic transmission, acting as an agonist on various serotonin receptors, and as a modulator of sigma-1 receptor activity. Regarding its structure-activity relationships, we can say that the R1 substituents can vary, as we can notice in the analogs shown here, and that these substituents can help to enhance bioavailability. Since when R1 corresponds to a hydrogen atom, and it turns out to be the active metabolite of fenfluramine, known as norfenfluramine. On the other hand, the R2 substituents can be the trifluoromethyl group or the trifluoromethyl as in the case of Tiflorex. The history of this drug has ups and downs. It was patented by researchers from a French research center. Initially, it was introduced in France as an antidepressant, and during its use, its activity as an appetite suppressant was discovered, and thus it was later introduced in the United States for the treatment of obesity, and it was used for decades, until it was withdrawn from the market in 1997 due to serious cardiovascular adverse reactions. However, it was later discovered to have antiepileptic activity and was repositioned for this indication, with lower doses and reintroduced in the United States by Zogenix under the brand Fintepla. It is currently indicated for the treatment of 2 types of severe epilepsy that are often resistant to other drugs. It is administered orally with good absorption, and its half-life is relatively long. In general, with the doses used for epilepsy, it is well tolerated. The risks related to serious adverse reactions are considered minimal, and its use also requires monitoring of these reactions. Here are some relevant physicochemical properties. The retrosynthesis and resulting synthesis will be presented in the following videos. Thank you for your attention.